Well, today it's a customer repair day. It's Friday, and in all the years that I've been doing these videos, I think we started in 2014, we've never had a Harrier CB come in. So this has come in from a regular trade source, and it's immaculate. It's even got the factory seals intact as the others topple over. Meanwhile, I had an idea. Radio Cruncher has got his new, to him, Stabilock 4040 test set, and one of the routines is to do the receive sensitivity using the Synad facility on the instrument. And when you buy these kind of things like CB radios, one of the things in the instruction book is how sensitive the radio will be. The manufacturer says it will do so many microvolts for various points of signal to noise ratio, which is defined as Synad. And one of those standard points is 12 decibels. Now I quote, when I do these service jobs, I quote the 20 decibel reading, which seems to be one of the popular ones, the 12 decibel reading, which is the technical normal one, and the 10 decibel one, which is the looks good on paper one, but it isn't. So we're going to do this, and I'm going to add a field into our database, and I'm going to put in, every time I get a particular set in, I'm going to measure its sensitivity, and I'm going to put in what that sensitivity was in two boxes. I'm going to have a best sensitivity box, and I'm going to have a worst sensitivity box. So as we get a set in, we're going to start off, and let's say the customer's radio does 0.5 of a microvolt. Well, then I'll write that in the best box. And then later on comes along another radio, and this battered heap of junk is 0.45 microvolts. So that's now in the better box, and we'll shift the customer's result into the worst box. Then this one comes along, and it does 1 microvolt. So we get rid of the one in the lower box, and we replace it with that one. So that's what we're going to do. So we're going to end up over a period of years. Isn't this pointless? Because these are 38 years old. We're going to end up over a period of years with a bit of a database with best and worst case scenarios on sensitivity. Now the manufacturer says something like these are better than 1 microvolt for 12 decibel Synad. Radio Crunchers had, was it his Binatone 5-star, 0.25 or something. Absolutely incredible sensitivity. And we're getting sets today, and it's varying just as much. You know, some of them are off the clock and some of them are atrocious. So don't think buying a new set gets you more range. It does not. I promise you, it does not get you better range. It just gets you more facilities and more compact sets, and probably more difficult or impossible to repair. So that's the customers, and that's the one we're going to do the video with. Then behind the scenes, I'm going to do our battered radio. Look at that. It's got some lovely, it's got the light, so it looks like it's been pried off, stamped flat on a piece of concrete, and then glued back. And then we've got that one which looks like an honest one. Ours has come, our bottom one has come with the factory mic, and the customer's comes with the factory mic. We'll be putting a standard mic to that. So that's the plan. We're doing the customer set. That goes back to him. We'll do the usual tests on with Mr. Chippy. We're going to do our ropey set. We're going to do our not ropey set. I'll be putting ours through the dishwasher, and then we're going to take those sensitivity readings. I'm going to put a sticky note on each of the sets as to what those are, and we'll enter that into the database. And then I'm going to be really, really embarrassed if the customer's turns out to be the worst. You know how it's going to go, don't you? The chances are that the battered one, it will be the best one of them all. So we'll get on with it. That's enough preamble. This is a good start. 30 seconds later saying enough of the preamble. So I start trying to take the lids off, and what do I discover? That all the screws have had the heads drilled out, so you can't take the lid off. Every one of them has the head drilled out. Okay. He's lucky I'm also a church organ builder. We'll use some other techniques. So what I've done here, there's several ways we could do this, and we have it. Eventually, we do have screw removing drills, but I don't want to drill them out because then I've got to start re-tapping it and all that. So what I've been able to do is to get the right size side cutters onto the very carefully, because what you don't want to do is slip. So I've got the right kind of side cutters just onto the edges there, and we can just grip it enough to start turning it, and then we can hopefully just use, although there's no slot there, we can't use that. I'll try a precision flathead screwdriver and see if what's left can, yes, in this case we can just, I could turn this out by hand as well. So that's that one out. I thought this was going to be straightforward, but no, I still can't get that one to go, even though I've started it, and I can't get that to go. So we've got 5 out of 6 out. So we have got new screws in stock. I don't know what this is. No one's going in my rig. Alright, that's that one. So we're just down to one. Wow, well that took some doing. I don't know why I'm keeping the screws. I could have put them straight in the bin. Do not break this seal. We'll do it neatly. And the other side's gone. Well, there's one thing, and it's not going to be full of modifications, is it? It even smells of new Cybernet CB radio. That's got the smallest Cybernet speaker ever, hasn't it? Do you remember the one in the Binatone 5-star, which was huge? Now, on the lower models with the Cybernet 134 chassis, you have one receive stage less, and so there's no coil there. You start getting all the receive circuits on the Rotel 230, which is one of the reasons we used the Rotel 230, which has been carefully selected and tuned, as our test set. So the performance of these and all the lower Cybernet 134s isn't quite as good as the upper and the middle ones. So your the Rotel 230 is going to work the same as the 240, you just get more knobs on the 240. But some of the surprise sets are sets like the, let's say the Harvard 420M. That's got all the receive circuits, and they get overlooked because Harvard's other lineup, you've got sets like the Good Buddy, which are atrocious, although they work for some people. So that, you know, the people gets tired with the same brush. It's like the Binatone, the 5-star is absolutely outstanding, and yet, you know, they did the one which is up there, Route 66, yes. So what we're going to do, as ever with these, is we'll start with the VCO. And it's channel 40, and we're looking for 4 volts. It's going to help if I switch on the power supply, make sure it's 13.8 volts, because I tell you what, it's not. It's the just turn. There we go. We're going to use the customer's power lead for all 3 sets, because there's no point otherwise. And your attenuator switch for the high-low power is on the back, and it's arrived in the low. I can't even say it. The low power position. Do you know what? Let's just have a look at these serial numbers while we've got the back to us, and we've got some time. I'm out to do some shopping for an elderly parishioner shortly, so I thought we'd get on with this because it's going to be a bit longer. So what have we got here? In fact, I could probably read them off the monitor better. So 1122. So those two start 1122. Yeah, they all start 1122. So 1385 is the customers. 2424 is our ropey one, and 8313 is our nice one. So the customers is the oldest, our ropey one's the middle one, and our reasonable one is the newest. It's like train numbers. This we could be collecting serial numbers of CB radios. Right, we'll plug the customer's beautiful microphone in. We've got a really rubbish walkie-talkie lined up on Sierra Hotel 1 Tango Sunday. Do you remember we did the really horrible rubbish one, which even sound distorted 100 yards away, though it doesn't sound distorted if it's a bit closer? Well, I think I found one which is worse, the Harrier CB27, and we've got a pack with 2 in. And last night I put a battery in one of them just to see if it worked straight out of the box, and I could get it to receive. We were using that base station we have with a dummy load in the back, and I could get it to receive 2 yards from the base station. I wonder if it says the words long range on the box. The rubbish ones often do. Okay, let's power it up. And we've got nothing, so let's see where I've gone wrong. It's my handy crocodile clip, isn't it? Because these have been tinned, that's it, we've solved it. I'll just bring this camera out a bit so we can actually see the display. So I want channel 40 on the radio. And we just heard it receive as it went past whatever the signal generator was on. And I could do with a crocodile lead clip. I'll tell you what, we'll use a red one for negative. That seems clever. So it's the a quick change of glasses. So it's the far side of resistor 4 on channel 40. We want 4 volts. Plus or minus 0.1. we're going to adjust the coil here. Is it T1 for 4 volts? So in this case we're tuning down slightly. There we go, 4 volts. Going to transmit. Let's make sure we are into the test set. We are. 3.86. So that wants to just pop up a fraction. And it's the CT1, the red trimmer capacitor there. These are very fine adjustments. .98, 3.99. I think that's safe. We'll go back to receive, and it's still within what we'd expect because they are interactive. Now we go to channel 1, and we need to check that it's somewhere between 1.8 and 2.5 volts. So in receive, that's where we are, and in transmit, that's also where we are. So that's the VCO set. And I say time and time again, if you don't do the VCO because you can't be bothered, on sets like these, and especially the Cybernet economy chassis used in the Amstrad, then you can end up, you get in your car and it's cold and you don't find that any channels over channel 30 work because it is temperature dependent and all that. So that's us done. I'll set up the camera onto the power meter and we'll proceed to tune up the transmitter. So here we start with T2 for the transmitter. Just move that so it's not behind the inlay picture. Now this microphone's playing up, so we'll probably, I think we'd better just deal with this now. I'm hoping it's just a dirty switch contact. And not a duff lead. We'll switch the radio off so we don't be constantly going into transmit. So using the Servicol Super 10, spray that into the switch. I'll switch the radio back on. Yeah, it seems to be that's the problem. You probably notice that when we use standard mics, it's this pattern of mic that we use to be our standard mic, this type, not the coffin ones. So there's no reason, you know, we just have found that these are better feel than the coffin ones. There's nothing there, you know. Well, the DM520s and these are DM510s or something like that. Right, let's try once again. We're going to transmit and we'll start with T2. Let's see what it's doing on transmit. I'm on the 3 watt. Oh, it must be on low power. We are. It's doing a good 3 watts. So what's it doing? It's doing spot on 3 watts. So that's what you'd expect for a set which is as it's left the factory. So just make sure that's peaked. The one under the wiring harness is T3. That's spot on. T4. Spot on. Now we move on to the ones which require the hexagonal tool. And no, you don't use an Allen key. There are these kits intended for colour TV servicing, colour TV alignment kit, spelt the American way, which are readily available. That's these, which come with the different colour tools with different hexagonal ends and an extender thing. They're not cheap, but they are readily available, and Rapid Online in the UK are one of the people who do them. I did import some from the United States at great cost when Rapid Online didn't do them. So it's the green one that I use the most. In fact, I don't think I use the yellow one a little bit, but there you are. So what we need to be doing is maximising L4, which is that one, and that's come up to 3.5 watts, and then L8 is it? L6, L8, 4.7 watts, and then finally L9. Now this is one of the radios that isn't going to kind of quite make the 4 watts. I'm going to go through them again. We'll just do the preceding one with it being interactive. Okay, so this is one that 3.5 watts is the maximum we're going to get. It isn't faulty; it's over the 3.4 mark, which is the minimum. So I'll just check it on channel 1, 3.6, channel 40, 3.5. So it's tracking between the channels, and this is now hot. So I'm sure that if you have left it 10 minutes and the transmitter's cooled down, it will probably be doing the 4 watts. And again, I've said time and time again, we're on this Marconi test set, which is to some extent looking at what's on 27 megs and not what's on other bits, other harmonics, you know. So if you put this on an ordinary SWR meter or something, I'll tell you what, we'll do that right now if I can find a patch lead. I'll just pause the video. So if we look at the meter on the inlay picture from the Marconi test set, we're now only doing 3 watts because it's passing through the meter and we've incurred a loss, which is another reason you don't ever release an SWR meter in circuit. There is an insertion loss. In this case, it's costing us ½ watt. In actual fact, it's in the rules. If you look up what the Radio Communication Agency, what they're called this week of calling themselves, what the CB rules are, it says don't leave an SWR meter in place. Not only is there an insertion loss, but the diodes can cause spurious emissions. So let's look at what this says. So this is in the 5 watt power function, it's in power, and the matcher's off, so it's oiled properly. And let's look at what this meter, which isn't a cheap and nasty one, it's certainly above average. It says we're doing 4.5 watts. So there you go. So when I say we're doing 3.5 watts, we're probably doing 5 cheaper meter watts. And if you'd like to think your radio is giving piles and piles of power out, as if you think it's going to make any difference, if you get yourself a Zetagi meter, you'll probably find that 4 watts equals 8 on one of those. It's actually laughable. We did a video 4 years ago on comparing power meters for any of you who want to look back on that. So that's the best we're going to get. It's 3.5 of my watts, 4.5 of the other meters watts, and we're all back to how it should be. Good. great. Right, we'll move on to deviation, and I need to look at the time, and there's no clock in sight here. The trouble is, if you don't see old people exactly on time, and I see her at 9:15, 7.5 miles away, they really worry. You know, you've got to be absolutely like clockwork with old folk. I can't say I'm going to be half an hour late because I was doing a CB repair, you know. Okay. Let's see what the deviation is. 1.4. Wallow. It just wants to come up a fraction. So the kind of Mike Gainey one, we'll take that to the centre. Wallow. That's dropped it slightly. And now we'll bring up the deviation with RV2. I think we'll try it about there. Wallow. No, it still wants to come up a bit. Wallow. That's it. Done it. So 2 on that meter becomes 2.2 with a whistle and a wallow, with an absolute maximum peak of 2.5, which we must never exceed. So that's done that. We want it to read 4 watts on the meter regardless of what it's actually doing. So red needle on a red background, and it's saying actually about 3.5, which is the truth, but we are supposed to set these to read 4 into the dummy load. There we go. Now we're going to check low power is 0.4 of a watt. And low power is 50 milliwatts. There we go, 400 milliwatts. Switch that back to normal. Yep, and now all we need to do is to pop the other camera on our frequency counter, and we'll make sure it's on frequency, and then I'll look at the time. So having switched to camera 3, let's see what it's doing. 2779110. What's more on frequency for some brand new ones, and they're supposed to drop with age. So what we're going to do is just pull that up a fraction. It's well within spec, it really doesn't matter, but it's we've got the reference crystal just here. We've got CT2, is it? Yes, it is. The red trimmer capacitor just there. And we'll just go in there and try and improve that. .2779124. I think we'll leave it at that. So that's brought it up. So that's the transmit done, and we'll go over to the receive, and I've looked at the time and I've got 10 minutes. So there we are in receive, and our signal generator is at 0.3 of a microvolt, which is absolutely great. So we'll put S9 on the signal generator, which is 100 microvolts for CB radio in the UK. And what we want, what we're looking for, oh yeah, maximum recovered audio. So it's transformer 12, which is just down by here, down the naughty corner. Looking for maximum amplitude. Radios with max on chassis, you know, like the Midland Precision series and of course the Maxcom 4E, 6E and all that, they can really go out in transit. So it's something you really have to watch on that chassis, but it's pretty stable. I've hardly touched it on this one. So okay, that's covered that. I'll tell you what, while we've got S9 on the radio, we may as well set the meter for S9. And look at that, it is bang on S9. What I will just do is demonstrate that the preset for there, if I can find it. So I'll put the light back on. RV3 is the one also in the naughty corner. Which is that one. So I can make that bad or whatever. We'll take it exactly back where it was, which was S9. You'll remember the 53 dBm 0.5 of a microvolt for S9, sorry, 0.5 50 microvolts for S9 is referring to HF amateur radio equipment, not to CB radios in the UK, so don't get misled with that one. Right, we'll get onto the receiver. So I'll move the camera onto the SINAD meter. So we'll want the meter, we're going, the better the signal, the more over to the left. As it gets better, I have to drop the attenuation of the signal generator, or you can't adjust it for maximum. So at the moment, I want it to be about 4 decibels on that meter. So I'm adjusting my attenuator for that, just like that. We'll start with transformer 5. Tell you what, that's taken some real adjustment. That has surprised me. I'll just move over to the next transformer, which is it 6 or is it not fitted? It's 7. Go back to that. Transformer 8. Transformer 10. And transformer 11 hiding under the wiring. So no improvement except a vast improvement with transformer 5. That is impressive. So we're listening to 0.15 of a microvolt. It's actually receiving off my clock that. I'm going to do these again. We'll do all 3 together, but the it says in the instructions in the service manual. This is the Rotel RVC230 service manual. So bear in mind it's got an extra receive circuit. But it does say better than 1 microvolt for 20 decibel SINAD. So what we'll just do is we'll put 20 decibel SINAD on, which is there. And it is 0.89, 0.88. So it certainly is better than. And for our 12 decibel point, it's kind of between ranges here. With around, it's 0.25. I'll just do that with the other range. And read it, see if there's a difference. So on the other range I'm getting 0.3. So there's some argument, isn't there? It's just between the ranges, so it's somewhere between 0.25 and 0.3. And then for 10 decibel cyanide we've got 0.24. So although these are calibrated, you know, there's going to be some slight discrepancy. Right, that's that done. We'll just set the squelch up. Turn the signal generator off. Set squelch to threshold. Switch the signal generator back on. And it's coming in at, well, it's going off at 0.6 of a microvolt. No, it's coming off at 0.5 of a microvolt, coming in at 0.65. So that's okay. Now we'll put the squelch to full. See when it comes in now. So we've got 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts. I want it to be 100. So we'll just pop that up a fraction with the preset here, which is RV1. So now it's coming in at S9 at 100 microvolts. So once again, we'll turn the signal generator off, squelch the threshold, switch the signal generator back on. It's actually coming in now at 0.3 of a microvolt. So that's absolutely beautiful. So radio done. I'll put the lids on it. Oh yes, it's hovering, isn't it? Before I put the lids on, I'll just put it on our aerial and we'll just see if there's anybody out there at 8:30 in the morning. So I'm still in bits. $19 Roger. Helps if I'm on high power. $19 Roger. Nobody out there, they haven't got up yet. Okay, so I'll go and do this shopping job. We'll get back and I'll have put the lids on this. We'll have run mine through the dishwasher and then we'll do some sensitivity checks on all the radios. But I'll do this one again when it's all back together. Right, cast about 4 hours later. Everything's put together, everything's been serviced, and we're about to make some notes on my late aunt's Sheffield Cathedral handy notepad. So, this is the scruffy one, which I think we came to the conclusion was the newest. And the reason this didn't work, because Mark ZX2 had put a red sticker on the back, was that the VCO was way out on transmit. It was actually way out on receive as well, but the reason it wasn't transmitting is the VCO was well out, and it's clearly been fiddled with, and it's doing they're all doing about 3.5 watts on our test set. So we all know that with the other meter it's 4.5 normal watts, shall we say, rather than industrial watts. So if I can find a pen, we'll start off like this. So they're all cold. So we're going to transmit from cold, and I'm going to put scruffy. That's its name. TX. Wrong scale. 3.4 watts. Receive. So receive let's have a look at what that cyanide meter says. As ever, I've knocked it off frequency. Helps if we plug the extension speaker in. So I'm spot on 20 dB cyanide on Mr. Scruffy, and let's see what we've got. Oh, not for 20, we're doing 12, aren't we? It'd be 0.95. We're doing 12. We're going to be in line with what Mr. Radio Cruncher does. RX 0.295 microvolts for 12 dB cyanide. And we'll stick that to there with the handy Scotch tape other brands available. Right, that's the Scruffy set. And when we do the on-the-air test, we're going to do the test with the customer set, and then I'm going to have him park up and we're going to talk to him on the other two, and we're going to have all three into our base station at the end. Now we're going to have the customer's beautiful immaculate set. There we go. So we'll start with transmit again. Here we go. Transmit. 3.55 watts. Receive. Tell you what, it's more or less the same. It is RX equals 0.285 microvolts for 12 dB cyanide. And the handy Scotch tape on that one. I'll put this to one side because this is the one we're testing later. And then my one with the better front, but the stuff on the top where something's been stuck to it. All my sets have been through the dishwasher. Well, the cases and fronts have, not the radio. Though have been known. Okay, so switch mine on. Now then, when I was working on this one, there was a capacitor in it, which I've got here, connected to our ECR meter, and it looked distressed. Now, if you look at the top of this capacitor, and I'll tell you what, we'll zoom this camera in because we can. Not quite got the focus beyond there. The heat shrink tubing, and let's look at a Duff capacitor I've taken out of a power supply. If you look at that one, there's more of the heat shrink tubing over the edge, and this one, it started to look like it's been circumcised. So it's got hot, and it's in the receive section in the IF. So I just think it's just one of those things. But it was a visual inspection, so I thought we would change it, seeing as it's my set, and they're all of about 12p. And let's see what it reads. So it's 53, it's supposed to be 47 microphones. Now it's starting to go high, and that's always indicative of them starting to fail. So you think, wow, it's doing 53 microvolts and it's only a 47. But I'll tell you what, we'll get a new one out. Here's a Billy No Mate's new one. I've not done this test before, this will be interesting. It's going to call me a liar now. That goes in the vertical filing cabinet. But what happens is the voltage drops off. So you tend to find if you've got things in valve circuits, these start to have problems. Yeah, well, you see, that's slightly low, and that's what you'd expect, because they're about 20% tolerance. But that is absolutely typical of a new capacitor. I'll tell you what, let's go for another new capacitor here. So we'll just do the same again with another new one. It's 44 points. So they tend to be on the slightly low side when they're new, and they tend to be rising dramatically when they're about had it. So don't get all excited if you think they're reading better than they should, because they're not. That's today's thing. I replaced all the screws in the customer's set. I'll just get that back to prove it. You see, they're all nice new screws now. And what we use are RS4830934 for those of you in the trade who have RS accounts. Right, back to this set. This is the one with which looks immaculate and comes with the Harrier microphone, but has a bit of this case situation. It really doesn't matter. So if you remember, our customer's one was the oldest, this was the medium one, and our scruffy one, I think it was that way around, was the youngest. Right, transmit. Notepad. Our complete set. In other words, it came with the mic, that's what I mean. TX. .36, 3.6 watt. Receive. C. And we've got RX equals 0.258 microvolts for 12 dB cyanide. So stick that on it. And you know what? You know our super special Rotel RVC230 that I think so much and was selected from amongst countless ones over the years. I wonder how special it is now we've been doing this comparison, though it does have an extra receive stage, so theoretically we would be better on bleed over and so on. So I'll tell you what, I'll do that. Do you know what? It's probably going to be the worst set we've got. Just do its power supply. Okay, so we'll now do this one. RVC230 TX. I think it's about time for a service, folks. 2.5 watts. Receive. Gonna knock it off frequency again. Oh no, I haven't. I knocked it back. RX equals .2 08 microvolts for 12 dB cyanide. I'm just going to pause the video. We're just going to pop the lids off and I'll just go through the transmitter on this. In actual fact, the test was flawed and it isn't doing 2.9 watts at all. I'd knocked the current limit on the power supply to 1 amp. Which is one of our presets, and unfortunately it looks like it was doing that kind of power. So keying it up again, it is actually spot on the 4 watts. So I'm just going to go back and check the other 3 sets to make sure that they are the power I said. Okay, so it did make a slight difference. It was on the preset one, which puts it on the 1 amp current limit. So these radios must be allowed to take up to 1.4 amps. And so we've got Mr. Scruffy at 3.9, my half decent one at 3.8, and the customer's one at 3.6. And of course it makes no difference at all, unless it's feet we're talking about. So let's look at the sensitivity. 0.258, 0.295, and 0.285 for the customer. So the customer's is the pig in the middle. So which one's the actual best? And it's our nice looking one. So it's got better receive, but 0.1 of a watt down on transmit. Our scruffy one is 0.1 of a is higher on transmit. And all this makes no difference, to be honest. But that Rotel 230 of ours, I'm not taking the thing off the pad, is now 4 watts. And it was 0.208. So, you know, that's why we selected that one. And in fact, we'll put that label on it to remind ourselves. Right, so that's the Harrier CB Bonanza. I've just realised something. If you can see the colour on this. Look how our non-scruffy one's faded in comparison to the scruffy one. And the customer's immaculate one. So there you go. We'll be doing our little scratchy corner test. And thank you for watching the Harrier CB triple radio super tune.